Hello. In this third part of the Improve series methodology, I'll look at the Analyze phase. You've presumably just viewed the Measure phase. In the Analyze phase, we'll look at a number of key concepts: diagnosis, evidence base, multiple angles, summation, Pareto's law, vital few, trivial many. We'll also look at several techniques, briefly. CTP identification, value-added analysis, failure mode and effect analysis, Ishikawa diagram, ICU, KU, 5Y, diagnostic worksheet and formulation, and the parking lot. In earlier videos, I looked at the define phase, or scoping, of the project. The measure phase, where you describe the process in detail, zoom in to identify the variables, and find measurement systems that will allow for listening to the voice of the process. Now we are into analyzing this data. Having identified the variable, having data, what is the data telling us exactly? The key principle that applies here is primum non nocere. First, do no harm. In order not to do any harm, you need a diagnostic. What exactly is the problem? Then you can start fixing it. Otherwise, you are messing with the process and probably doing harm to it. The output of the measure phase is a description of the process with measurement system. This is what you'll analyze to produce the diagnostic. The diagnostic, as our output, will be the input into the improve phase. Next video. We have data, so we can make the data speak and listen to it, thinking statistically. For example, imagine that we have data on the risk metric measured initially, and we have a number of days late in delivery of the project. Analyzing this with a regression line here tells us that there is a correlation. The two variables are linked, and this suggests some inner dynamics that will help us formulate the diagnostic. Imagine further that we can decompose the project that we've done in terms of the type of project, whether they're HR related project, marketing, finance, or other, and we are looking at the profit that we made on each of them. We can again make some inference on what's related to what. Having variables and measurement, we can correlate, see what moves together, what is totally unrelated, and what moves in inverse fashion. We could also plot, for example, the days late in terms of a time frame and see that there is cyclicality here on a trimester basis, that we tend to be late at the end of the month. For example, many companies have end of month rush, for example, to get the numbers right and meet the target and get the bonus. This is not atypical. The point here is that analyze the data. Once you've made sure that the data is worth analyzing, use all the tools that you have to make it speak. Second aspect to look at. If you see the process metaphor as a pipeline or a piping system, then the throughput is the value, and anything that contributes to throughput is value added. And non-value added are those activities compared to air bubbles, if you like, in the process, that don't add value, slow down the process, cause trouble, basically. The technique we'll look at, which is value added analysis, consists in identifying those bubbles and finding ways later in the improve phase to eliminate them, as I just showed. Key law here is Pareto's law, 80-20. 20% of the variable explain 80% of the variation. This is typical. You want to separate the vital few from the trivial many. This, by the way, is a typical Pareto diagram. You can make that easily in Excel, ranking variables in order of importance and having a cumulative curve which should show you the 80-20 typically. Let's go back to the software bidding example that we used for the measure phase initially and for the define phase as well. Let's focus on just one of these activities to illustrate some of the techniques that we can bring to bear to understand the process and the causes of the problem. Prepare rough cut technical solution. What's critical in there? The team would ask itself, imagine a group of experts from the various departments that works in the process day in and day out, asking themselves, what's critical here? What do we do that has to be exactly right in order for the project to be delivered on time, to avoid risk, to reach our profit target, and so on? The answers to those questions are CTP variables. And the goal here is to define them precisely, formulate them, measure them, or find a way to control them. These ways are ideas for solution that will be moved forward to the improve phase later on. We can also look at the failure mode. What could go wrong? What combination of variables would result in a failure? And which of those failures is most important? So the answer to what are the failure mode is failure mode identification. Specific set of circumstances which would result in a failure, which we would then rate in terms of the severity of the impact, the probability of occurrence, and the probability of that failure not being detected until the damage is done. The technique of FMEA consists in identifying those modes and calculating a risk priority number based on a multiplication of these three numbers. By the way, either value-added analysis, FMEA, if you go on the web and search these techniques, Google Images, for example, and YouTube as well, will give you all sorts of examples. Those are not new techniques. And they are relatively simple as we apply them here. And that their very simplicity makes them very powerful. Coming back to the piping example and the bubbles I was discussing, we can use this technique here, taking an activity, review proposal. How long does it take? In an ideal world, how long would it take if we had the right people? If we didn't have to inspect 3 times because we don't trust the person who does the job? If we'd optimize the layout of the work area? If, in an ideal world, how long would it take? Well, this is value added. This time that it would take is value added. The rest is NVA. A group of experts naming exactly what they would need to make this happen can identify the part that is non-value added and that the customer shouldn't be willing to pay for. You do this for all the tasks and you calculate the value added ratio as the total value added time over the total cycle time, meaning the time that passes between starts when and ends when. And this gives you a ratio. And you would like that ratio to be as high as possible, and you would like the cycle time to be as short as possible. Just measuring it tells you how far you are from an ideal that you will never reach. The further you are, and the more red zones there are, the more opportunity you have to reduce NVA and increase the value added ratio. So you have here an illustration of 3 techniques which look at the problem from various angles and are likely to make you see things which the other techniques will not make you see. It is beneficial to use various angles. First, not to leave any dark side that you don't see at all, any blind side that could really surprise you, get you at the end, and also to allow the team, which initially the members of the team are not a team, they're a group of people with different views, pretty sure initially that the other guy is the problem. So the more techniques that they use that tend to point in the same direction, the more they are reinforced and validated in their discussion, the more they can stand up as one person and convince their colleague that this is the problem. And that's critical to change management. Make your case. Another angle, again, If you start from the SMART statement and formulate it as a problem, we are late by too long in delivering our projects, or we don't make enough money, then you can do an Ishikawa diagram. Again, Google Images and YouTube, go for that. What are the causes of this? You get the causes identified in the fishbone or Ishikawa diagram. Of course, not all these causes are equally important, so you classify them. In ICU-KU, what are the biggest impact causes, the medium impact, the lowest impact? What's controllable, what is not? This is best done in post-it, and you move the post-it from here to there with the goal of focusing, of course, on the impacts that are strong and controllable. Those that are not very clear and you don't know how to attack exactly, you move to the 5Y area to dig to the root cause, or at least to the point where you clearly see the action to take to resolve the problem. This is a three-pack, really, of 3 techniques that do not proceed from the mapping, contrary to the previous technique, value-added analysis, the CTP, the failure mode. These are totally different, and they allow you to explore soft areas that will not be visible as you look at the flows of activity. You need to distill from this a diagnostic. Of course, as the team is doing these analytical tools, ideas for solution pop up. There are 2 big mistakes here. The first one, start discussing solution before you have found the problem and shared the problem with the rest of the organization. It's a waste of time, and it is counterproductive to do that. It's also a big waste not to capture these ideas. As you're analyzing a purpose of this, and it is human nature that you see fixes, you say the fixes. So we need someone in the team that we call the idea manager. He walks around with post-it. Anyone says, hey, why haven't we thought about that? All we have to do is. And then the idea manager comes in and says, oops, what's the idea, Paul? Shuts it down. Thank you very much. And he's got a 1-pager here, we call a parking lot, and he sticks the post-it to the parking lot. This is an idea for further discussion in the improved. Thank you very much, Paul. Move on. Result, after a while, you got a number of ideas. I had a team with 100 ideas on the wall. This reduces the stress of the team. This is raw material for the next phase as well. And a side effect of it is that people feel respected. It's not the time to discuss solution. And the coach will tell people, hold your horses. And yet people will have ideas. Shutting them down does not create exactly the right type of climate you want. Capturing the idea helps the team in reducing tension and making people feel respected. These ideas, again, are not discussed here. What is discussed here is how can we distill all these elements of problems into one diagnostic. We'll use a diagnostic worksheet and we'll synthesize and formulate. Words matter. Do not attack anyone. Make sure the formulation is not vague so that everyone agrees but it doesn't mean anything. Do not name anyone. Do not look for a guilty party. If the big problem with a process is that is a problem of attitude or one or two specific individual, then it's not a process problem. It's a human, it's a management problem. Management should detect that at the outset and not launch into a process improvement initiative in those cases. So words matter. They should be specific, meaningful, not attack anyone. If you attack me, I will use my energy to defend myself, not to solve the problem. Avoiding attack is a critical change management feature of this approach. Visually, you've got zones you've got risks, you've got the flows, you've got the critical variables, you've got the green zone and the red zones, you've got the causes. You distill all this, and the goal, as a doctor would, is to formulate a diagnostic from a mass of data. If you go to a doctor, he'll send you to have an X-ray analysis, MRI, blood analysis, urine sample. He gets data, some of which will validate each other, and some of which will form patterns that the expert that he is will recognize and be able to name. He'll make connections. This is what we'll try to do here. We'll summarize from each of the techniques that we have used, what have we learned exactly from that technique that we did not know before, and that we have to keep in mind at the moment of formulating the diagnosis. So technically, you go to the wall, post-its again. From the Ishikawa diagram, what have we learned that's critical? Formulate it. From the value-added analysis, what have we learned? The color coding here means that we find team, find links between those things. Either these things are complementary, they are part and parcel of the same thing, either they stem from the same underlying phenomenon. Whatever the links, that's up to the team. Finding the same thing 3 times is great, is validation. Finding complementary thing takes you a step further. So that's your, pretty much like the doctor would. This is your data, your worksheet in order to use your head, team, to formulate this and show it to your colleague. Link the thing. Distinct element from various techniques are useless. Linked element leading to a conclusion. This is an example taken from the book. You formulate it globally, and then you're specific and name the problem one by one in words that will be meaningful to people. Then you use it to convince people. The team, that was not a team at the outset, but that through this exercise becomes a team. Has many techniques. This is the base of the pyramid. And slowly you distill and you formulate and you come up with a demonstration with all this, being able to connect the dots for everyone. You show your techniques, you connect the dot you formulated, and then you listen with an open mind. If we forgot anything, please tell us. If we somehow in our logic, there are flaws, please point them to us. If you have other data that we don't have, please bring them to us. This, by the way, is done in an open forum before we move on to improve. We share the diagnostic, and any discussion of solution at this point is prohibited. This is no time for that. If we agree together on diagnosis, we will find a solution, one or another. We can discuss solutions later on. If you discuss the 2 things at the same time, that's a recipe for failure and confusion and frustration. The team presenting to their colleagues before moving on to the improve phase is pretty much like the lawyer again, to use another metaphor. The lawyer throughout the prosecution will lay various elements of proof, present, circumstantial, and he at the end will put all the proofs together in a convincing way, makes his case. In change management, making your case with data is not only convincing to change the process, it serves to change the organizational culture. It helps you show that evidence, well organized logically, gets you to the facts. And that's an essential step to get you to the solution. In short then, let's summarize what I've said here. Making changes without a diagnostic is more likely to do harm than good. Problem finding before problem solving. Critical to capture improvement ideas as they arise. It is equally important not to discuss them. At best, it's a waste of time. Most likely, it's counterproductive. A good diagnosis must be evidence-based. Look at the problem from all relevant angles. It should be made by an empowered team of equals and involve players from all relevant areas. A consensus on diagnosis is an essential asset when time comes to discuss actual changes. When sharing your diagnosis with the rest of the organization, discussion of solutions should not be allowed. It's pretty hard to predict with any degree of certainty which tool will be the most useful. Further, each technique approaches the problem from a different angle. Thus, using many different tools is good practice. It leaves no stone unturned and brings the team together as well. The formulation and choice of words matter when it comes to formulating the diagnosis. Assigning blame is counterproductive. So is naming names. If the fundamental issue is a person or attitude issue, what's required is management action, not process improvement. Careful thought should be given to this possibility at the outset before embarking in a project, which would be painting you in a corner. This completes part 3. It will take us to the next video, starting from this shared diagnosis based on data and with a lot of ideas in the parking lot that was generated earlier. We